Now we are going to see about temperature and Zeroth Law of Thermodynamics. So let's look at the concept of Zeroth Law of Thermodynamics. If object A is in thermal equilibrium with object B, you can see here object A is in thermal equilibrium with object C. It's B, and object C is also in thermal equilibrium with object B. You can find here. Then we can tell that object A and object C will be in thermal equilibrium if brought into thermal contact. This is all because of the reason that temperature is the only factor that determines whether two objects in thermal contact are in equilibrium, that is considered to be thermal equilibrium or not. You can see here how the temperature and Zeroth Law of Thermodynamics is possessing the equilibrium state with the view of energy level in terms of 2D perspective. So we have taken this experimentation with the 2D analysis of GTech laboratory. Now let's see some example. So the experimentation of bottle, balloon, pail, hot water. So first we have to first place balloon on the mouth of the bottle. You can see it. And after that, we need to put the bottle in the pail and pour some hot water which observes something. We can see that now. So you can see how the balloon is getting to be blown off. The reason is nothing but the hot water and the temperature which has been drastically makes the balloon to expand. So you can see the experimentation of GTech which has been done in our laboratory. So this is one just example of heat. As you see, the balloon expanded because when hot water was added, heat transferred from the surrounding to the system. Before the system managed to transform, the heat input into work is getting to be stored inside the system as the energy, that is nothing but the internal energy. Now let's move on to the concept of specific heat. So specific heat is a capacity of any substance which is defined as the quantity of heat required to change the temperature of a unit mass of the substance by 1 degree. Different substances have different capacities for storing internal energy. So you can find some example over here. So this is one such experimentation of specific heat, where you can find a water heater over here and you can find the heat exchanger over here. You can find the change of temperature over here, which we have stating that the quantity of heat required to change the temperature. So this is nothing but the water heater where we used to took bath. You can find how it is getting to be exchanged of energies. Considering the specific heat, it is considered as thermal inertia. The more heat energy it takes to rise a substance of temperature, the more heat energy is given up by the substance as it cools down. So this is the concept which is lying under the specific heat. We shall now see about thermal expansion of materials. The example is this one. Suppose we have taken a rod with some initial length, that is LO, at some initial temperature as TO. When the temperature changes by del, then the temperature, that is the length, will change by an amount of del L. These experiments shows that del L is directly proportional to del T, which is provided than about 100 degrees Celsius. So because of this reason, the material is getting to be expanded. Some of the examples are bimetallic strips. Some more examples are thermostats, and some examples are expansion of joints in roads, sidewalks, etc. Sometimes you can see the road which is getting to be expanded in the joints. This is all because of the heat, that is the thermal expansion of materials. And we have a depiction over here. Free thermal expansion at a temperature of 20 degrees Celsius will be having an anode over here like this, and an electrode which has been placed in between the anode and cathode, and this seems to be the interconnect. So this is one such example. It's just the material which is having the thermal expansion at temperature of 20 degrees Celsius. If you consider a bimetallic strip that consists of two metals of different coefficients of thermal expansion, you can see A and B in the figure, which is getting to be bent when heated or cold. So over here you can find the thing of strip which is straight enough, but you can find a bent over here because of heat or cold. You can see a strip of bimetallic strip in this state. And also in terms of convection is considered to be the flow of fluid which we knew. So here convection is said to be the fluid flow due to a difference in temperature, such as warm air rising. And also the fluid carries the heat with it as it moves on. So this is also considered to be an example of thermal expansion.